Hi guys, welcome to the channel. So today we are going to start with the topic of UV spectroscopy. So first of all, UV spectroscopy is also known as electronic spectroscopy. Now why this is so? This is for the reason that it involves promotion of the electrons from highest occupied molecular orbital to lowest unoccupied molecular orbital, that is also referred to as HOMO and LUMO. So this will be, HOMO will be the ground state and LUMO will be the excited state. So UV spectroscopy involves promotion of electrons from ground state to the excited state. Ground state is also called as HOMO and excited state is also called as LUMO. Now the next question arises, why we need UV spectroscopy. That is the main application part of UV spectroscopy. So what are the various applications? So it is used to identify various APIs or drugs, you can say. API is what? API is active pharmaceutical ingredient. For example, paracetamol, caffeine, these are all APIs. So we can use UV spectroscopy for the comparative study of various drugs. We can use it to identify various APIs used in pharmaceutical industries. We can also use it to find out the number of conjugated double bonds present in any given molecule. We can use it to identify or to distinguish between the alpha beta unsaturated carbonyl compounds from their beta gamma analogues. So we can discuss about this later on, but for now you need to know that we can distinguish between the alpha beta from their beta gamma analogues. One more application is to distinguish between the homoannular and heteroannular dienes. Now what are homoannular and what are heteroannular dienes? We will discuss that shortly in the upcoming videos. Now these were some of the applications of UV spectroscopy. There are many applications to it, but these are some of the applications of UV spectroscopy, and this is why we need the UV spectroscopy. So it is basically the study of transition of electrons. These are the electronic transitions which are taking place from the ground state all the way up to the excited state. Ground state is referred to as HOMO, highest occupied molecular orbital, and the excited state is known as the LUMO, that is lowest unoccupied molecular orbital. And we have discussed some of the application parts of it. So we will continue with the UV spectroscopy in the upcoming videos. For now, this is main of the introductory part. So from now onwards, from the next video onwards, we will discuss about the UV spectroscopy. So I forgot to mention the range. So UV range is from 200 to 400 nanometers and visible range is 400 to 800 nanometers, roughly same. So from 200 to 800 nanometers we have UV visible range. So there are two absorption laws, and combining those two absorption laws we have one single law which governs the UV spectroscopy. I hope you all have heard about it, that is Beer-Lambert's law. So we will start with that topic only from the next video. So I hope the introduction part is clear to all of you. If you have any doubts, you can comment down below. I'll try to answer all of them. So I hope this video was a little bit helpful for you. So far that's it for this video. Thank you so much for watching.